Hey everyone. For this video, I'm going to be going over the second part of the parabola notes. So on Monday, we were going through parabolas in terms of conic sections. We introduced the focus and the directrix and a new way to kind of consider the equation of a parabola that lets us look at it kind of opening up or down, or even right or left. So we're not talking about functions necessarily. But these are our conic section kind of ideas for parabolas. So we got the equations here to remind us. We were working with the letter A on Monday. P is the same type of thing. And it'd be good to look at this every once in a while when going through these notes. Think about, where does the focus have to be? The focus is kind of always in the cup part. The directrix is always on the other side, but the focus and the directrix are always the same distance away from the vertex, either up and down if the x is squared, or left and right if the y is squared. So compared to Monday, we're going to be working with equations in general form. It's not given to us nice and factored, so it's not easy to tell what the vertex is, where the focus would be, where the directrix would be. So that's what we're doing today, is taking this general form stuff and trying to write it in such a way that we can identify the vertex, focus, and directrix. And then we're going to sketch. So looking at the first one, I guess I should mention, if you didn't watch the completing the square video, you might want to do that, because I'm going to be assuming you have a basic understanding of completing the square. Let's get to it. For this first one, general form, y squared minus 4y plus 4x plus 4 equals 0. This is something that if you typed it in instead of that 0, you just typed in the rest of the stuff into like Desmos, it would be a parabola. What would the parabola look like? We're going to try to figure that out. How we do this: group the y's and x's on different sides. We're always going to keep the squared thing on the left, but that's just not something you have to do, but it's going to make it look like our equations up here. So for number one, what we're going to do is we're going to take the 4x and the 4 and move it to the other side. So y squared minus 4y equals negative 4x plus 4. So I'm going to group the y's on one side. I'm going to move everything to the other side, keeping the y's on the left because we have that y squared. So completing the square is necessary here, because completing the square is going to allow us to find the vertex. Nice and easy like. So completing the square, we look at this. Half of that is negative 2. We always take half of that. We square that. Negative 2 squared is 4. So we're adding 4 on this side. And remember, whatever you add to one side, you must add to the other. Completing the square allows us to take this y stuff and write it as y minus 2 quantity squared. That's what it factors to. Now on the other side, we're also going to want to write x in kind of this parentheses-like notation so that it matches with our equations up here. In fact, it's going to match something similar to this y minus k squared equals 4p x minus h kind of deal. So, oh, someone should have called me out. That's supposed to be a minus. Sorry about that. Negative 4 plus 4, well, that's 0. So this is negative 4x plus 0. We're going to rewrite this in a little bit of a weird way here, but I'm hoping you're cool with this. I can rewrite negative 4x is negative 4 times the quantity x minus 0. Now, why am I doing that? Because how are we going to find our vertex? We're going to look at those numbers that are next to the x and y. X minus 0 gives us our x-coordinate of our vertex, 0. And the y minus 2 gives us our y-coordinate. So the vertex is going to be at 0, 2. The y part is squared, so this thing either opens right or left. This negative right here hopefully gives you the idea that this thing opens left. And if I'm quick sketching, if it opens to the left, the focus is to the left of the vertex, the directrix is to the right. So how are we going to figure out where they are? We need to figure out what A is. And if this coefficient in front of the x stuff for this one is -4, well, -4 equals -4a. So what is our a value? A equals 1. So that means this distance right here is 1, this distance right there is 1. Sorry, I'm drawing on my awful sketch down in the bottom there. If our focus is to the left, we take our vertex and move that point 1 to the left, which would make it at -1, 2. And our directrix will be a vertical line. So that's going to be x equals, and that's going to be 1 to the right of the vertex. So the x coordinate of the vertex is 0, moving it 1 to the right would be at 1. So what would a decent sketch of this look like? Let's draw our axes. Our vertex is at 0, 2. Our focus is at -1, 2. Our directrix is the vertical line x equals 1. And then we're just drawing a sketch, so it's just going to be a parabola opening to the left, because y is squared and we have a negative coefficient on the other side. So completing the square, let us find the vertex. We need to find that a value to figure out the focus and the directrix, which helps us draw our sketch. So it would be a good time to pause, think about this. See what you're comfortable with, see what you're not. I'm going to do one more, and then I'm going to tell you to pause and try these other two, and then come back and I'll have the answers written. So for number 2, looks like everything's already kind of separated for us. So instead of having to move stuff from one side to the other, it looks like the x stuff is on one side, the y stuff is on the other. I'm going to give myself some space, though, to complete the square here. We're completing the square with the square part, so we're only working on the x side. How do we complete the square? We look at that 8, we take half of it, which is 4, we square that, so we're adding 16 over there. We also must add 16 to the other side, don't forget that. How does x squared plus 8x plus 16 factor? That factors to x plus 4 times x plus 4, which we write as x plus 4 squared. Then on the other side, 4y, 8 plus 16 is 24. And we're going to take out that 4 again, because we have to think about what a is. So we're taking out a 4 out of 4yn plus 24, so we get 4 times the quantity y plus 6. Written like this, I am hoping that you can see the vertex is -4, -6. To find the focus, we have to think about which way this parabola is facing. The x is squared, so that means it's either up or down. The a part is positive, so that means this parabola, is facing up, which means the directrix is under, the focus is above. So from the vertex, we have to go a units up to get to the focus. And what is the a value? Well, in front of our y stuff would be 4a, so 4 times a has to equal 4, so a equals 1 in this case. So from our vertex, we're going to go up 1. The y coordinate gets 1 bigger, so our focus is at -4, -5. And our directrix, horizontal line, which means y equals, and it's 1 because a is 1 beneath the vertex, so the y coordinate goes from -6 to -7. A quick sketch of that. So we're down here in the third quadrant. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. So at -4, -6 is our vertex. And -4, -5 is our focus. Y equals -7 is our directrix. And then we're just going to draw a sketch of our parabola opening up. Something like that. Not perfect, but it's a sketch. It doesn't have to be. So again, I want you to think about, we went through completing the square to get it into this factored form so that we could tell where the vertex was. I thought about which way is this parabola facing, up, left, down, right. That's going to tell me how to think about where my focus is, where my directrix is, figure out that A value, add it, subtract it however you need, and then sketch. So here's what I would like for you to do. It'd be really awesome if you tried the next two. Number 4, dealing with some decimal type stuff a little bit. Pause it. I'm going to come back. The answers are going to be written momentarily. I'm going to pause my video and write the answers so you can check, and I'll talk through them briefly, but a little bit faster than these others. So pause and try. Come back. I'll have my answers written. Hi. I lied a little bit. I'm going to finish up number 4 talking about it, but number 3's answer is above, written down. I completed the square. I saw that it opens to the right. I calculated my A value is 2, which means my focus is to the right of the vertex. My directrix is to the left, and it's vertical. Vertex of 0, 1, focus at 2, 1. Directrix, the line x equals -2. Number 4, you had to move x back to the other side. Completing the square, we add 36 to both sides so that we can do x plus 6 squared. And then we factor out a negative so that we get y minus 36 with a negative out front. So the x is squared, we see a negative, so this opens down, which means our focus is underneath our vertex and our directrix is above. What's tricky about this one is looking at where our 4a would be. So our 4a is going to equal 1. Or ignore the negative. You know it's down. We're just finding a distance for a. So a in this case is actually a quarter. So that makes this just a little bit harder because you're dealing with a small number, not a whole number. The vertex is at -6, 36, looking at the x and y. The focus is underneath the vertex, so we have to move down by a quarter, which means we're going to be at -6, 35.75. I'm not going to write that as a fraction. That's something over 4. I'm going to be lazy. Our directrix is a horizontal line, y equals. It's going to be a distance above the vertex, so that would be at 36. I was right. 36.25. Now this is not the easiest thing to draw. It's up in the second quadrant, way up here. The focus is a little underneath. The directrix is a little above. You can label stuff better than I'm doing, but the sketch should be facing down, basically. So I'm hoping that went okay. Hoping your answers were good. If not, go back and double check. See where you went wrong. I won't be able to answer emails really quick, but if you send me emails, I might be able to help you out today. What we're going to do for the last couple problems is some applications. So I'm going to get started with this graph one here. Write the equation from the given graph. So we're going to write it in our conics type way. So how are we going to do that? We're going to use this vertex to get us started, and then we got to find our a value, which should be kind of familiar. It's facing down, which means that the x is squared, and that there should be a negative in front of the y stuff. So we have x minus h squared equals -4a x minus y minus k, excuse me. What is our h and k? 3 and 4 if you can read it. So x minus 3 squared equals -4a y minus 4. Now we're done when we calculate a. We're not shown the directrix, we're not shown the focus, so we have to use something else in this problem, which looks like we're given the y-intercept. You could be given any point to do this, but we're given the y-intercept. If we plug in these values for x and y, we will be able to solve for a. So let's do that. We're going to plug in 0 for x. We're going to plug in 1 for y, sorry. 0 minus 3 is negative 3 squared is 9. Negative 4a, 1 minus 4 is negative 3. Negative 3 times negative 4 is 12. So we get 12a. We divide by 12. So a is equal to 3/4. And then we kind of put that all together. X minus 3 squared equals negative 4 times 3/4 times x, excuse me, I keep saying that, y minus 4, to get our final answer of x minus 3 squared. Negative 4 times 3/4 is negative 3, y minus 4. There is our conics way of writing this parabola. I'm hoping that made sense. All right, I'm going to do one of these word problems. I'm going to ask you to try the other one because it's similar, and then I'll write the answer for it. But these can be tough. These can be tough. The shape of a satellite dish is a paraboloid of revolution. What does that mean? Take a parabola and spin it around in a circle like this. You'll get kind of like a bowl. That's what they mean by paraboloid of revolution. If a parabolic satellite dish is 6 feet across the top and 2 feet deep, find the location of the receiver. So I don't know if you know this about satellite dishes, but the beams hit the dish, and no matter where it hits the dish, the beams bounce to a singular point. And that's what these dishes are for, is that no matter where the beams hit the dish, they get bounced to one point. And that point is actually the focus. So let's think about a cross section of this satellite dish. We're like cutting it right down the middle. Sorry, I'm sliding this thing all over. We're going to cut it right down the middle, and we're looking at it from the side. So here is our satellite dish. And there's a point here somewhere where no matter where the beam strikes, it always bounces to that point. That is going to be our receiver, which happens to be where our focus is. So we're going to do some math to find our focus. How do you do these problems? Well, it says it's 6 feet across the top and the dish is 2 feet deep. How are we going to come up with this? We're actually going to put this on the axes. And we're going to make the vertex of our parabola 0, 0. You can make it whatever you want, but I recommend 0, 0. That's going to make your life easier. Why does that make our life easy? Because now we have this parabola, we know its vertex, and we actually know, I keep sliding that over, we actually know 2 more points on this vertex. What's this point over here on the right? If it's 6 feet across, well, from the middle over to one side is 3 feet. So the x value would be 3, and it's 2 feet deep, so that would be 3, 2. And then over here on the other side would be negative 3, 2. We're going to use this vertex and one of those points to figure out how to find the focus. So let's start with, this is a parabola facing up, so it's going to be x minus h squared equals 4a, y minus k, positive 4a. Our vertex is at 0, 0, so it's x squared equals 4a times y. We don't even have to worry about the zeros. Now, how are we going to solve for a? Because the a is going to help us find where the focus is. We need that a distance to find where the receiver goes. Use one of the other points that we have. It's not a y-intercept in this case, but we're going to use 3 for x and 2 for y, or you can use negative 3 for x. It doesn't matter. You'll get the same thing. 3 squared equals 4a times 2. 3 squared is 9. 2 times 4 is 8a. We divide by 8, so a is equal to 9/8. So how do we write our answer for this? The receiver is 9/8 of a foot, we'll say above the vertex. You also might see me call this the base in other work. The base of the satellite dish. Wherever the base is, I guess even if it's tilted, 9/8 of a foot away, 9/8 feet away, that's where you would put the receiver. So if we were thinking about it as coordinates on the coordinate plane, that'd be at 0, 9/8. That'd be where the focus is. So for this next problem, if you look in the middle of the bridge and you make the middle of the bridge 0, 0, read that problem and see if you can figure out how to get this one started. I'm going to pause and write some things down and then talk through the rest, but I think it'd be a really good idea if you tried to get this one started thinking about this application problem for the satellite dish above. All right, so I started the problem here. I'm hoping you did too. That looks like negative. I'm sorry about that. That is a positive. Okay, so the bridge from, from tower to tower is 400 feet apart. The height of those towers is 100. So if we made kind of the vertex of that parabola we see in the middle at 0, 0 again, the height of those towers, one side would be 200, 100. The other would be negative 200, 100. That allows us to start our equation. X minus 0 squared equals 4a. Y minus 0 squared, again, it opens up, so the x is squared, the a is going to be positive, or the thing in front of the y is going to be positive. We can plug in one of our points, 200 for x, 100 for y. 200 squared, oh, I hope I don't mess this up, is that 40,000? Yeah, I think that makes sense. And then 4 times 100 is 400a. Dividing by 400, we get the fact that a equals 100. So what's our equation of this parabola? It would be x, you know what, let's not even write the zeros. It'd be x squared equals 4 times 100, 400, y. That would be our equation. Now, the thing that we didn't do for the problem above is this asks, what is the height of the cable, sorry about the typo, 50 feet from the center of the bridge? So we're over here at 50 somewhere, and we want to know how tall it is. So we're finding the y-coordinate when the x-coordinate is 50. So maybe not simply, but we plug in 50 for x, and we solve for y. 50 squared is 2,500. We divide by 400. The zeros cancel. 25 over 4. What is 25 over 4? 4 goes into 24. 6 times 1/4. So that would be a height of 6.25. And we're working with feet, because 6.25 is 25 over 4. All right. I feel like that is enough math stuff for you. You're going to have a worksheet to work on that we're going to talk about when we come back together on Friday. I'm hoping this was helpful. Again, go back. You can rewatch this as many times as you need. This stuff can be tough the first time you go through it. So give yourself a little bit of time to think about it. Let it sink in a little. Make sure to try that worksheet to put this stuff into action. Bye-bye.